Welcome back, Year 11. Today we're going to be talking about multiple derivatives. So, we need to understand that you can differentiate more than once. If you differentiate f of x, you can rewrite the derivative of f dash x. But if you differentiate f dash x, then we're going to call it f double dash. That means you've differentiated the original and the derivative, you've differentiated twice. If you want to differentiate the second derivative, you can write f triple dash x, which is the third derivative. You could write them like this. If you differentiate y, you get dy dx. Or if you differentiate dy dx again, it's d squared y dx squared. If you want to differentiate again, it's d cubed y dx cubed. The powers tell you how many times you've differentiated. You could also have, there's your original, there's your first derivative, there's your second derivative, there's your third derivative, and so on. Normally we only focus on the first two derivatives, but we need to understand that you can keep going on. This part here is one that's commonly misunderstood. If you see d over dx, when you see this, dy dx, what it actually means is d over dx of y. It means differentiate with respect to the letter x whatever y is equal to. And we don't like writing it with the brackets, so we just say dy over dx. It means differentiate with respect to x, whatever y is equal to. So you can see an example here. If y equals x cubed, then the derivative is 3 goes out the front, 3x squared. Or you could say the derivative with respect to x of x cubed is equal to 3x squared. This part here is the language of if you work backwards. We say if the derivative was 2x, where did it come from? Well, it came from x squared plus maybe a number, but we'll talk about that soon. So let's try some questions. First one. Find the equation of the tangent to that curve at 2, 4. Well, first thing we need to do is find the derivative because the derivative gives us the gradient at a point, the gradient of a tangent at a point. X to the power of 4 becomes 4x cubed when I differentiate it. Minus 2x cubed, 3 times 2 is 6, so minus 6x squared when I differentiate it. 4x to the power of 1, the 1 times 4, 4. There is my derivative because the minus 3 drops out. Now, when x equals 2, and why did I choose 2? Because that's the x value of my point. X is 2 there. So when x is 2, the derivative is equal to 4 lots of 2 cubed minus 6 lots of 2 squared plus 4, which equals, what is that? 2 cubes 8, so we get 32, take 24 plus 4, which is 12. So the derivative is 12. So now we need to find the equation of the tangent. So let's find it. The equation of the tangent. We're going to use the formula y minus y1 equals mx minus x1. Y minus, there's my x1 and y1 values, because that's the point I know, and there is m. I found m. M is 12. So we can plug that in. So y take 4 equals 12, bracket, x take 2, expand it out. Oops, need an x there. Take 24 plus 4 to both sides if I leave it in this form. And there is my answer for the equation of the tangent. Question 2 says find the equation of the normal. Well, we've been given what y is equal to. I want to find the derivative. So the derivative is equal to, looking at the x cubed, derivative of x cubed becomes 3x squared. The derivative of minus 3x squared becomes minus 6x minus 1. So when x equals 1, the derivative is 3 lots of 1 squared minus 6 lots of 1, take 1, which will give minus 4. Also, when x equals 1, not the derivative, y. I plug x equals 1 back into the original here to find its y value because I wasn't given the y value of the point and I need that to find an equation. So y is equal to 1 cubed minus 3 lots of 1 squared minus 1 plus 1, which gives minus 2. So to find the equation of the normal, we're going through the point 1, 2. The gradient of the tangent is minus 4 because that's from the derivative. So the gradient of the normal, would equal minus 4 over 1. Turn that upside down, it becomes plus 1 over 4, the gradient of the normal. So let's find the equation of the normal now using our foot rule. Y minus 2 is the y value, equals a quarter, x minus 1. I'm going to take the 4 in the denominator and times it across to the left-hand side. Gives me 4y take 8 when everything is multiplied by 4, equals, I'm just left with a 1 because the 4 got multiplied to the other side, so 1 times x take 1 is x take 1, x take 4y plus 8 across there, and I get plus 7. There's the equation of the normal in general form. Question 3 says to find the first 5 derivatives. Well, let's see what happens. The first derivative equals x to the power of 4 will become 4x cubed. Minus 6x cubed becomes 3 6s are 18, so it becomes 18x squared. 5x squared, 2 5s are 10, becomes 10x. Minus x to the power of 1 becomes minus 1x to the nothing, or just minus 1. There's the first derivative. I have to find the first 5 derivatives. The second derivative. Look at 4x cubed. 4x cubed, 3 4s are 12. It becomes 12x squared minus 18x squared. 2 times 18, 36x, plus 10x, derivative of that is 10. The third derivative. Look at 12x squared. 2 times 12, 24, x to the power of 1. 36x has a derivative of 36. The fourth derivative. 24x will differentiate to give 24. The 3, 4, 5, fifth derivative is 0. And there are the first 5 derivatives. Let's go to question number 4. Now we're working backwards. It says find the family of curves whose derivative is dy dx equals 5x squared plus 2. Now normally you take the power, times it to the number at the front, and decrease it by 1 if you're differentiating. But I'm working backwards here because I know the derivative. So what I have to do is work backwards. Now, before I took the power, times it out the front, and then decreased it. So to work in the reverse process, I want to increase the power by 1. So when I look at this particular term, just do each term individually. When I look at the power of x, I increase it by 1. It becomes 5x to the power of 3. So it's 5x. So I increased the power by 1. And when I was differentiating, I times by the derivative of the power. I'm going to divide by the derivative of the power. So when you're working backwards, you add 1 to the power and divide by the new power. That's the process. When I look at the plus 2 term, plus 2, if I want to, that came from a 2x, differentiating 2x gave 2. So if I want to go backwards, I need a 2x because the derivative of 2x gives 2. Plus, could have been a number on the end, I don't know. So that represents all curves where c is just any number, that when you differentiate them, the derivative is 5x squared plus 2. And let's just do a quick check. if I look at this, y equals 5x cubed over 3 plus 2x plus c, where remember c just as a number. The derivative is equals, take the 3, times it out the front. 3 5s are 15, you get 15x to the power of 2 over 3 plus derivative is 2, and the derivative of any number is nothing. 15 over 3 is 5, which is what I started with. Let's go through this process again. When you're working backwards, you have to add 1 to the power. X cubed will become x to the power of 4, and you divide by the new power. Minus. Add 1 to the power, so 12x will become 12x to the power of 2 over 2, and at the end I have to put a plus c. And c just represents any number at all. So this represents all curves that when I differentiate it, I get x cubed minus 12x. Pretty tricky. That actually is called the process of integration, which is an entire topic by itself. And we will be doing that later. So looking at question number 6 now. It says, find f double dash of minus 2. I have to find the second derivative and then plug x equals minus 2 into it. So let's find the first derivative. X to the power of 6 becomes 6x to the power of 5 when I differentiate it. 2x cubed, 3 2s are 6, becomes 6x squared when I differentiate it. 13 doesn't have x's, it drops out. Second derivative. Now 6x to the power of 5, 5 6s 30. X to the power of 4 plus 6x squared, 2 6s 12, x to the power of 1. I have to find the second derivative when x is minus 2. And you put that into your calculator and you will get, and I'm just putting it into a calculator now, to the power of 4, and you get 456. That's the process there. Well, time to do some questions. Enjoy yourself. Bye for now.